Hi, first grade teachers. Welcome to the Unit at a Glance video on demand. The purpose of this video is to provide you with an overview of the standards, intended pacing, and sample instructional strategies for Unit 4A, Meaningful Measurements. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 4A. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. Remember, some AKS and IOAs will appear multiple times throughout the year to build and deepen student understanding. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Let's look at the AKS and IOAs we will be teaching in this unit. Unit 4A has one AKS, AKS 6. The parts of AKS 6 we will focus on in Unit 4A involves using appropriate tools to measure, compare, and order length, as well as telling time and measuring elapsed time to solve real-life problems. Under the AKS, you will find the Indicators of Achievement, or IOAs, that we are teaching at this time. The IOAs go into further detail about the expectations for the standard. For AKS 6, we are working on the IOAs 6A and 6B. IOA 6A focuses on estimating and measuring lengths using non-standard units, comparing and ordering up to 3 objects using the recorded length measurements, and describing the objects being compared as longer than or shorter than. IOA 6B focuses on telling and writing time to the hour and half hour using analog and digital clocks. And new this year, measuring elapsed time to the hour, on the hour, using a number line. Now let's look at the pacing guide to see how the AKS and IOAs have been paced out over the course of Unit 4A. In the top portion of the pacing guide, we see the name of the unit, the big ideas, and the suggested pacing. Unit 4A will focus on measurement and data reasoning. The suggested pacing for the unit is about 3 weeks. In the next box, we see the AKS and IOAs that will appear in this unit. For AKS 6, we will begin the unit with the IOA 6A. The left column of the pacing guide will list the progression through concrete, representational, and abstract strategies. The bullets indicate the learning objective for the day, as well as any suggested manipulatives. The right column of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. You will either see instructional resources linked for the numeracy components of a traditional teacher-led lesson or a task-based lesson, which will be your full numeracy block for that day. We begin the unit with about 3 days of concrete instruction on estimating and measuring the length of objects with non-standard units, like color tiles, snap cubes, centimeter cubes, 1-inch paper clips, and construction paper. The length unit students use should correlate to a standard unit of measure, like inches, centimeters, or feet. So this means we wouldn't want to measure an object with crayons because a crayon doesn't correlate to a standard measurement unit. First grade is a student's first experience with measuring length, so it's important to provide multiple concrete opportunities for them to line up the non-standard unit with the end of the object being measured and lay the unit side by side along the object without any gaps or overlaps. After measuring the objects, students will also compare their lengths and order the objects by length. As we move into about 2 representational and abstract days, students see images of objects and count the length objects and count the length units to compare and order the objects, as well as estimate length by reasoning about the size of a unit and order objects given their lengths. We then move into IOA 6B, telling time. This will also be first grade students' first opportunity to learn about telling time on analog and digital clocks. We have paced about 5 days of instruction on learning the parts of an analog clock, what the numbers represent, how the hands move, and telling time to the hour and half hour. You have 2 clock manipulatives to build this understanding. The number line clock is a new manipulative where the hands, hours, and minutes can be removed. The Judy clocks we know and love show the relationship between the hands as time passes around the clock. Both are essential tools to teaching and learning this concept. At the representational level, students tell time by looking at images of clocks or will draw the hands on a clock to represent the time. You will also notice a day here where we have woven in IOA 6D. That's our data IOA. So students will be generating some data from their time survey, collecting that data and organizing it on a tally chart to represent the information gathered and to be able to ask questions and answer them from that data. We will continue to use both clock manipulatives as we move into about 3 days of exploring the concept of elapsed time. Students will relate elapsed time to real-life scenarios and measure elapsed time to the hour on the hour using a number line. They will find the end time, the time that has passed, and the start time by counting forward or backward by ones on a 1 to 12 number line. Elapsed time problems will not cross between AM and PM. Chapter 3 of the video will highlight specific instructional strategies that will be utilized in this unit for the IOAs 6A and 6B. Please refer to the ATS, Analyzing the Standards document, for guidance on additional instructional strategies for each IOA. Let's begin with IOA 6A, estimating, measuring, comparing, and ordering length. Okay, so as we begin, first here, I've got an object, a mini stapler, and students should be able to use a non-standard unit. I have color tiles here. Remember, you want to use non-standard units that correlate with a standard unit of measure. So these color tiles do correlate with 1 inch. So I'm just going to place 1 color tile right now because I want to do a little bit of estimating before I actually measure the length of the stapler. So from looking at the size of the object, the size of the stapler I'm measuring, and comparing that to the size of the length unit, I can see that 1 color tile isn't enough to measure all the way to the end of my stapler. But it also doesn't look like I'm going to need too many more color tiles to equal the length. So based on that, it looks like it's about halfway already. My estimate might be that it's going to take about 2 color tiles. right? So that's how we want to do that estimation piece is look at the size of the unit I'm using to measure, and then look at that compared to the length of the object to make a reasonable guess, an estimate. Okay, so another piece here when I'm actually measuring the object is we want to make sure that students are laying the length units, the color tiles, side by side. They're not leaving gaps in between. They're not overlapping, that it's the same size unit, right? So if I'm using these color tiles, it doesn't matter that they're different colors, but they're all the same size. So I'm using the same size length unit as well. And then I can see that from the start to the end of my object is 2 color tiles long. Okay, so I'm going to go ahead and label that right beside my stapler, because not only do first grade students measure the length of one object, we also can measure in order to compare and order up to 3 objects. So here's another common classroom object right here, an expo marker, that I'm going to use the same units. I'm going to use some color tiles to measure. All right, again, thinking about estimation. Okay, I can see 1 is not enough to measure the full length of the expo marker. I think it's definitely going to take more than 2, probably more than 3. So I might estimate that the length is going to be about 4 color tiles long based on that. Okay, and then again, we're lining them up side by side, making sure we don't leave any gaps between the units and we don't have any overlaps. Okay, so this expo marker is actually about, students will count 1, 2, 3, 4, 5 color tiles long. So here, my estimate didn't turn out to be the same as my actual length, but it was close. So it was a reasonable estimate. Okay, so I'm going to label the length of my expo marker. If I was comparing just these 2 objects, we can also describe that comparison by saying, I know that the stapler is shorter than the expo marker because 2 is less than 5, or I could say the expo marker is longer than the stapler because 5 is greater than 2. But what I'm actually going to do is bring in a third object. So now I have my glue stick. Okay, so same process. Let's take a look, do a little bit of estimating. It's definitely going to be longer than 1 color tile. I think it's also going to be longer than 2 color tiles. So my estimate might be 3 color tiles long. Then I'll lay my color tiles side by side until I reach the end, and I can see that, yes, it is 3 color tiles long, just like I estimated. So now that I've measured all 3 objects and I have recorded their length measurements, what first grade students now can do is put these objects in order based on their length. Previously, if we're thinking about comparing this new standard and how is it just a little bit different from what we've done in the past, we would have just visually lined these 3 objects up and just compared and ordered their lengths that way. But now we actually are going to use these recorded length measurements. We're going to use these numbers just like we compare and order numbers to help us compare and order length. So looking at our objects here, if I were going to try to put them in order from longest to shortest, I can see that the expo marker is the longest object because 5 is greater than 2 and 5 is greater than 3. So that's how I know it's the longest. So I'm just going to move these around a little bit to put my longest object here. Right, so now that I need to compare the stapler and the glue stick. Okay, I'm going from longest to shortest. So I might say, oh, I know the glue stick would come next because 3 is greater than 2. Right, so the glue stick is longer than the stapler. So I'm going to slide him up. Okay, and let's just check and make sure that the stapler is indeed the shortest object. So if I'm comparing these numbers, I see that 2 is less than 3. 2 is also less than 5. So yes, the stapler is the shortest object. So my objects are now in order from longest to shortest. Now let's take a closer look at IOA 6B. Telling and writing time, and measuring elapsed time. Let's begin with telling and writing time. So I have here your 2 clock manipulatives. These are Judy clocks that we have always had in the past that are great. And then our new clock manipulative is our number line clock. So when you see that in the Analyzing the Standards and on the pacing guide, these are the clocks we're referring to. So let's look at this new manipulative and see how we can use it with our students to help support building that conceptual understanding of a clock, what the numbers on a clock represent, and use these hands. So the cool thing about the number line clock is that it comes apart. So I can remove the minute hand and the hour hand. I can also remove the minutes, and I can remove the hours. Okay. So what's kind of cool with this is if we first start with, let's look at the hours. Okay, if we flip it over, it actually has the numbers in a nice straight line. Here, we can make that connection between a number line that students are familiar with, and then how a clock, the numbers on a clock, are just a round number line, right? So we can straighten it out, and we can also put it back together and make that circle to make that connection. We will also be using this number line part when we get to elapsed time as well. This will help make those 1 hour jumps moving forward and backward. But for now, we're just going to make the connection that the numbers on a clock are just a round number line. Okay, the minutes, really for first grade, we don't need to worry about all of these minutes, but one thing that it is really helpful with is to see that in 1 full hour, there are 60 minutes. So when we're measuring to the half hour, we can use this to find, oh, halfway through an hour is 30 minutes. So that's why we say 2:30 or 6:30, because 30 minutes have passed. That minute hand has gone halfway around the clock. So in that aspect, that will be helpful for your first graders. You'll see that in one of the small group moves. So as I put our minutes back on our clock, the cool thing about these hands coming off is I'm sure you've also noticed in previous and current lesson plans, we mention one-handed clocks to start building some of this understanding of what the hands mean and represent. So the minute hand, if we point this minute hand, let's start with at the 12th, right? We know that that's the start of a new hour. We would write 00 for the minutes, and we would say o'clock, right? So you could just show students a one-handed clock with the minute hand pointing on the 12 and ask what possible time it could be. So you're looking for them to generate really any hour on the clock. It could be 6 o'clock. It could be 10 o'clock. It could be 4 o'clock. Right? But we know it's o'clock. It's the start of that new hour. But if I pointed the minute hand straight down at the 6 and said, now what time could it be? Now you're looking for students to recognize that it has to be on a half hour. It could be 4:30, could be 2:30, it could be 11:30, but we know that it's at that half hour. The hour hand is even cooler though, right? So with our hour hand, if this hour hand is pointing directly at a number, then we know that it's 1 o'clock because the hour hand hasn't moved at all yet. So it's 1 o'clock. Or if it's pointing directly at the 5, we know it's 5 o'clock. So this helps students really focus on that placement of the hour hand to predict what time it will be. So let's say I scoot it now just a little bit so it's in between the 5 and the 6. So students should recognize that, oh, it's not 5 o'clock now because the hour hand has moved halfway, getting closer to the 6. But it's also not 6 o'clock yet because it hasn't reached the 6. It's halfway between. So that's how we know that it's 5:30. Okay, this will really help that very common misconception that first grade students have when telling time to the half hour. Oftentimes we'll hear them say that this is 6:30, right? Okay. Let me put my hands back on because I want to show you one limitation with this clock and why we want to make sure that we are still using both of our clock manipulatives. So this number line clock is going to give us a lot of great features. However, when we're showing students how the hands on a clock move as time passes, this is where we want to go back to that Judy clock. So notice what happens. Here, both of my clocks are showing 3 o'clock. On my Judy clock, as I slowly move this minute hand, you can see that the hour hand naturally moved as it would on a real clock, right? So now when I read the time as 3:30, my hour hand is where it would be, right in between the 3 and the 4. However, if I do that same thing on my number line clock and I move my minute hand down to the 6, the hour hand doesn't move with it. Okay, so this is going to look like that real time where that hour hand really would be. This is going to create some misconceptions here. Okay, so with the number line clock, students actually have to position both hands to show a time. But if you want them to naturally see that hour hand moving and what happens as the minute hand moves around the clock, the Judy clock is going to be what you're going to want to use. I also wanted to highlight for you the new component, the new piece of this IOA, which is elapsed time. So I'm really excited that first graders are going to get the chance to start exploring this concept of elapsed time. And they are only going to be measuring elapsed time to the hour, on the hour, right? So we're just jumping by whole hours. And the times that they work with for these elapsed time scenarios, they won't ever cross from AM to PM or PM to AM, right? So as we're counting, we won't have to say 11, 12, 1. Okay, it'll stay either all in the AM or all in the PM. So we're just starting to explore this concept with them. So I have a problem here from one of our lesson plans, and we're going to kind of think through this by solving this problem. So Ethan's family leaves to go to the beach at 6 a.m. His mom says it will take them 5 hours to drive there. What time will Ethan get to the beach? Okay, if you notice, this problem does mention that it's a.m. Okay, so that's also something that we're just kind of exploring and touching on the concept of. First grade students are just going to kind of pay attention to AM and PM. It won't be assessed as far as, is this an AM activity or a PM activity? They'll continue understanding that into second grade. But really, we're just thinking about, oh, it's 6 a.m. That's 6 o'clock in the morning. So they must have gotten up early to start driving to the beach, right? Just kind of connect it to the real world, real life. So this is a scenario with the elapsed time where it says in your IOA that students are going to solve this problem using a predetermined number line. Okay, and this is what that means. It just means a number line that already has 1 to 12 listed out for the students to be able to access and use. So each of the numbers on a clock for the students, because we don't need a 0, right, on our number line. And we don't need to go beyond 12 and go to 13 because we know as a round clock that this just starts over again, counting at 1. So just 1 to 12. And this is where our number line clock can come in handy because we can remove the numbers and I can actually line it up here and make a connection between the numbers going around my clock and this number line that we're going to use to show how each of these numbers represent 1 hour passing on the clock. Okay, so I'm going to scoot this over because I'm going to switch out here. Remember, I want to use this Judy clock when I want to show the hands naturally moving around the clock. So the first thing we would do is model setting our clock to when Ethan's family leaves to go to the beach, right? I know the start time in this problem. I know when they start driving to the beach. I know it's 6 a.m. So on my number line, I can come put a point right on the 6. Okay, and his mom says it will take them 5 hours to drive there. So as each hour goes by on the clock, I'm also going to make a hop on my number line. Okay, so we can model this for students so that they can see, oh, the minute hand went all the way around, one full rotation. It's back at the 12. When I read my clock, I can see that it's 7 o'clock. I can represent that with 1 hop on my number line. Okay, that was 1 hour. Okay, move it all the way around the clock again. That would be 2 hours have gone by. I can tell the time and read that it's 8 o'clock. And also make another jump on my number line. I've made 2 hops. 2 hours have gone by. 3 hours. Now it's 9 o'clock. 4 hours. And it's 10 o'clock. 5 hours have gone by. I make the 5th jump. I can see on my clock that it's 11 o'clock. I've also landed on 11 on my number line. So what this is representing for students is the start time was 6 o'clock when they started driving. My 5 hops represent the 5 hours it took to drive there. So the time they will get to the beach is 11 a.m. It will be 11 o'clock when they get to the beach after 5 hours go by. So in this problem, what we were determining was the end time. We knew the start time. We knew the elapsed time, how much time was going to go by. What we were figuring out was that end time. First grade students will also explore scenarios where they might know they left to go to the beach at 6 o'clock. They know the start time. They got to the beach at 11 o'clock. They know the end time. And then what they have to determine is the elapsed time, right? So they would make these hops and figure out that, oh, it took them 5 hours to drive there. And then another scenario they might encounter is if we said they wanted to get to the beach by 11 o'clock. It's going to take them 5 hours to drive there. What time should we leave? Okay, so this is a situation where they were looking for the start time and they're going to have to start at the end time and now count backwards, right? But first grade students can do this. We've been counting forwards and backwards through 120 since the beginning of the year. So now we're just counting between 1 and 12, forward and backwards, making these hops to represent each hour going by. At the representational level, we would just see this. They're going to be able to do this thinking and do this work on a number line without that concrete manipulative of the Judy clock.
The Georgia DOE's Comprehensive Grade Level Overview states, in mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. Thank you for joining us for this unit at a glance.